So, you've been assigned to participate in a layer protection analysis, or LOPA study. LOPA studies are not that different from other process hazard analysis studies, such as HAZOP or What If. We're still looking for answers to the same questions of: what could go wrong? How bad could it be? How likely is it? What is in place to prevent it? And do we need to do anything else to reduce this risk? But there are new terms and acronyms to know, as well as calculations to understand, to be able to participate most effectively. Firstly, if you have not yet seen our short video on participating in any type of PHA study, please go and watch that one first, at the link shown on the screen, since all of those concepts also apply to LOPA. Also, at the end of this video, there will be a cheat sheet shown with key terminology, acronyms, and concepts to help kickstart your LOPA session. LOPA is a PHA methodology that is used for three main purposes. One, more precise estimation. We take a closer look at potential hazardous scenarios with a rational, risk-based analysis. A semi-quantitative approach is used, which means that we use frequency numbers and probability math to get a more precise picture of the risk, but we are still using some assumptions and simplifications, and so the calculations are not as detailed as a full quantitative risk analysis. This more precise and granular view allows us to more fully understand the potential for the hazardous scenario, while reducing the biases and unstated assumptions that can cause inaccurate estimation of the risk. We can get a more complete risk picture. In LOPA, we can get a clearer picture of the overall risk posed by a process by considering multiple causes of the same consequence. While the risk of each individual HAZOP scenario may appear tolerable by itself, when the cumulative impact of multiple causes of the same consequence is considered, it may turn out that the scenario is not actually tolerable. Note that not all organizations use LOPA in this manner. However, we see this aspect of LOPA as one of its key strengths. If there are, for example, 10 different ways to overpressure a piece of equipment and potentially kill someone, we want to know how that combination of related scenarios affects our overall risk. We may need further controls to drive to a truly tolerable risk level. Or, alternately, we may find that there are adequate controls in place already, and therefore we have a good confidence that we are meeting our required risk tolerability as set by the operating company. Some risks require higher reliability protections than can be achieved using a basic process control system. LOPA can help to determine if and when it makes sense to design a safety function to a higher reliability, such as a safety instrumented function, or SIF. Each SIF is part of a safety instrumented system, or SIS, which is a safety-only computerized system designed, tested, and maintained to rigorous standards to ensure that the high reliability is achieved. If your process includes, or may include, an SIS, LOPA will be used to calculate the required reliability of each safety instrumented function and its associated safety integrity level, or SIL. This is called SIL determination, or SIL-D. LOPA is a common methodology used for SIL determination. Your facilitator will provide you with more information if you will be performing SIL-D in your LOPA study. Because LOPA studies are more detailed than HAZOP or What If studies, each scenario requires more information and time to complete. Therefore, most organizations perform LOPA on a subset of scenarios, which may include any of high potential severity or risk to provide assurance that sufficient risk mitigation is provided, scenarios that are mitigated by a SIF in order to calculate the required reliability and SIL rating for that SIF, and complicated scenarios that require a closer and more detailed look than is available in higher level PHA studies. In LOPA, many of the concepts are similar to those you will have already come across in other PHA methodologies. However, most concepts are approached slightly differently and are assigned different terms in LOPA to highlight this change in approach. Causes become initiating events. HAZOP studies may refer to the chance of an event occurring as a probability, frequency, or likelihood, and these terms are usually used interchangeably at that stage. In LOPA, we use frequency to discuss how often we expect a scenario to occur. Frequency is given in events per year. So for example, a frequency of 4 per year means that the event is expected to occur on average 4 times per year. A frequency of 0.1 indicates that there is a 10% chance, on average, that the event will occur in a given year. Initiating event frequency values are determined based on the specifics of the event in question, information and standards from the operating company, industry publications, and/or data such as from the Center for Chemical Process Safety, or CCPS. A safeguard is referred to as a protection layer. We can only rely on independent protection layers, or IPLs, which are protection layers that meet the following criteria at a minimum. They need to be specific. The IPL is designed to prevent the scenario in question. They need to be independent. The IPL is adequately independent of the initiating event and other IPLs to prevent a potential common cause of failure. It needs to be dependable. The IPL can reasonably be expected to take the system to a safe state. In other words, it is designed to the correct set point, capacity, size, response time, and so on for the scenario that it is required to prevent. And it needs to be auditable. There needs to be a way to check that the IPL is functioning correctly, which includes maintenance and testing, and documentation is kept verifying that these actions are done, and that the IPL can reasonably be expected to be in working order. Safeguard credits become probability of failure on demand, or PFD, for each IPL. This is the probability that a given IPL will fail to successfully perform its action when demanded to. PFD is given in probability per demand, and therefore is a unitless number between 0 and 1. A PFD of 1 means a 100% probability of failure, and therefore indicates that the IPL cannot be relied upon. A PFD of 0.1 indicates a 10% chance of failure on demand, and therefore 90% reliability. In some cases, higher reliability safeguards can be considered, such as a PFD of 0.01, which indicates a 1% chance of failure with 99% reliability. A PFD of 0, that is to say perfectly reliable, is impossible, because every device and system includes some potential that it will not function correctly. The reliability of an IPL can also be represented using the risk reduction factor, or RRF, which tells us how much the IPL reduces the risk. For example, an RRF of 10 reduces the risk by a factor of 10. RRF is calculated as 1 over PFD. The sources of PFDs for IPLs are the same as for initiating event frequencies: company guidance or standards, industry publications, and other data sources. Enabling events, or EEs, and conditional modifiers, or CMs, come into LOPA. An enabling event, EE, represents something that needs to be occurring at the time that the initiating event occurs in order for the chain of events to start that could lead to the LOPA consequence. For example, the hazardous scenario may not occur unless the system is operating in a certain mode, or the ambient temperature is above or below a certain value. EEs are applied to each individual initiating event. A conditional modifier, or CM, represents something that needs to be in place for the full impact of the LOPA scenario to be realized. For example, this might include the probability that someone is present in the area of a hazardous release when it happens, or the probability that a flammable release ignites. EEs and CMs are not the same as IPLs. IPLs are items that are specifically designed and implemented with the intent to prevent a hazardous event from occurring. EEs and CMs represent the probability that certain conditions are correct at the time of the event for the hazardous impact to occur. As such, they can be considered closer to luck than to a designed protection layer. Both EEs and CMs are given a probability of occurrence. Care must be taken that these considerations were not already included in another item to avoid so-called double dipping, or taking credit for the same thing twice. For example, an EE may have already been implicitly considered as part of the initiating event frequency, or a CM may have already been implicitly considered when determining the worst credible consequence. Mitigated risk ranking is replaced by mitigated event frequency, or MEF. The mitigated event frequency is an estimate of how frequently the hazardous impact is anticipated to occur. It includes consideration of the initiating event frequency, the probability of failure on demand of each appropriate independent protection layer, and the probability of each enabling event and conditional modifier. I know, it's a lot. We have that cheat sheet coming up. Tolerable risk ranking is replaced by tolerable event frequency, or TEF. Also known as tolerable frequency, TF, or target mitigated event likelihood, TMEL, the mitigated event frequency needs to be the same as or less than the tolerable event frequency in order to be considered tolerable. The TEF is set by the operating company and is dependent on the severity of the scenario in question. TEF is given in events per year. For example, a TEF of 0.001 indicates that the scenario is not tolerable unless there is a 1 in 1,000 chance or less that the scenario will occur in a given year. Because we deal with very small numbers in LOPA, you will often see frequencies and probabilities expressed as scientific notation, such as 1 times 10 to the minus 4 or 1e to the minus 4. Ask your facilitator if you're not sure about a given number, but here are a few examples. For example, 1e to the minus 1 means a 1 in 10 chance per year, and 1e to the minus 2 means a 1% chance per year. When discussing PFD numbers using scientific notation, the exponent is the number of orders of magnitude of risk reduction. For example, a PFD of 1 times 10 to the minus 2 would be 2 orders of magnitude of risk reduction, and therefore reduce the risk by a factor of 100. LOPA uses frequency and probability math to calculate the anticipated frequency of a hazardous impact. The math is relatively straightforward, but because it deals with decimals and fractions, it can be hard to visualize it. Ask your facilitator for clarification or explanation for individual scenarios, but the short version is that for each initiating event, we determine the mitigated event frequency, or MEF, for each initiating event that can lead to the consequence in question by multiplying the initiating event frequency by the relevant PFD of each independent protection layer and the probability of each enabling event or conditional modifier. The MEFs for each initiating event that can lead to the same consequence are then summed together to get the total MEF for the LOPA scenario. If the MEF is greater than the TEF, it means that we expect the scenario to happen more frequently than required, which means that we need further protection. If the MEF is equal to or less than the TEF, it means that we have met the tolerability requirement. Note, however, that meeting the TEF should be seen as a minimum requirement. In some cases, it may be appropriate to control the risk further than that minimum requirement. If you haven't spent a lot of time in LOPA sessions, this all might sound like a lot of acronyms and steps, but don't worry, we'll guide you through it. The way that you can best contribute to a LOPA is the same as for any PHA. Actively participate, share your knowledge and expertise, respect other team members' points of view, and maintain that sense of vulnerability. However, also bear in mind that due to the extra complexity of the calculations, it is easier to get lost in the process. And so it is important to ask questions whenever you need to so that you fully understand the scenario. Remember, if you're confused about a calculation or concept, it's likely that someone else in the room is too, so help them out by asking the facilitator to clarify. Shown on screen is a cheat sheet of some of the key terms, acronyms, and concepts that will help you follow the LOPA session more closely. Feel free to take a screenshot or contact us at the email address shown for an electronic copy. Thank you for taking the time to participate in this session, so you can be well prepared to participate in your upcoming LOPA and do your part to protect the people and equipment in your process and safeguard the environment. Just like with PHA, this video will help you survive your LOPA, but we didn't have the time to dive into the concepts in any detail, and there is a lot more that we had to leave out. If you want to get a solid understanding of how LOPA works and how best to use it, please consider our training courses on LOPA participation, or one of our other courses on process hazard analysis, process safety management, and safety instrumented systems. If you have any questions, please reach out to your Watchmen representative or visit our website at www.watchmanisc.com. Thank you, and please have a safe day.